So they okay, so these color bands they represent the resistance values and tolerances. So the resistors are usually tiny in shape. So you can see here person is trying to fix this resistance on some circuit board. So they are usually tiny. So it is difficult to print resistance values on them. Okay, it is difficult to print. So you can even see one more circuit board there where resistors are fixed here. So since they are very tiny in shape, so and since it is difficult to print resistance values on them, so color bands are printed on them to represent the electrical resistance. So usually the color coded resistors, they are most common type of color coded resistors are 4-band color coded resistors. So you can see here on this 4-band color coded resistor, there are 4 colors. Okay, so you can see there are 4 colors. Among these 4 colors, this is one color. I will just expand it. So you can see this is one color, second, third, and fourth. Total 4 colors are there. Among 4 colors, 3 are the resistance values, one is the tolerance value. Okay. So this is 4 color code, common type of resistor. So the instead of 4-band color code, you can the 5-band color code are also available. So 5-band color code. This is you can see five colors are there total. Among these 5 colors, 1, 2, 3, and 4. These 4 are the resistance values, whereas the fifth one is the tolerance value. So this is our tolerance value. The fifth band is the tolerance value. So total 5 colors will be there. Okay. So these are the resistance values. This one is the tolerance value. So and so instead of 5-band color code, so we can even the 6-band color code is also available. So you can see here total 6 colors are there. 1, 2, 3, 4. Okay, and 5 and 6. Total 6 colors. So among these 6-band color codes, these 4-band colors represents the resistance value. Fifth band represents the tolerance value, whereas sixth band represents the temperature coefficient value. Okay, so here first four represents the resistance value. Okay, resistance value. Okay, this represents tolerance value. Okay, sixth band it represents what? Temperature coefficients. So this fifth band and the sixth band color coded resistors, they are used for higher precision. Okay, so higher precision resistors, the 5 coded or 6 banded 6 code. Okay, there's okay. So I'm trying to adjust the volume because there is a lot of disturbance for me. Okay then. So high precision resistor is a resistor which is more which with a more accurate resistance value and smaller temperature coefficient, okay, than standard resistors. Okay, these precision resistors, you can even call them as film or foil resistors. Okay, so this 5 band and 6 band color coded resistors. Okay, so the so this precision resistors, whether it is 6 band or 5 band, sorry, whether it is 5 band or 5 band or 6 band, the precision resistors, their tolerance value will be very low, usually below 1%. Okay, the tolerance value of these precision resistors, high precision resistors, that is 6 band or 5 band, their tolerance value is usually 1%. Okay, less than 1%. Okay, so and the temperature coefficient will also be very small. Okay, that means that they can maintain stable precision even when temperature fluctuates. Okay, and these precision resistors, they will have very good long-term stability. So these are all the advantages of using of this 6 band and 5 band color coded resistors. Now if we see the composition of this band, 4 band, 5 band or 6 band resistors. So you can see inside this coded resistors, carbon composition will be there. You can see this black portion, that is the carbon composition, and above the carbon composition, insulating cover is provided. Okay, and this is the lid. Okay, you can see a thin wire or rod, you can say that is the lid. And above the insulating cover, you can see color coating. Color coating is provided. Okay, coating of color you can see. Okay, so this is our color coded resistor. Now, so let us consider the most common type of color coded resistor. So the now if you see this color coded resistor, most common type of color coded resistor, that is 4 band color coded resistor. Okay, the 4 band color coded resistor I am taking here. So you can see 4 colors here, 1, 2, 3 and 4. Okay, so this we will start from left side. Always you must start reading the resistor color from left side. Okay, so you must start reading the color from left to right. So left one, okay, and you must end at right side. So here, if you start from left side, you can see the band. This is our first band. You can call it as band A. Band. Okay. So band A is the first band. The first band is no, you can call it as first band is the band A. Second one is the band B. Third one is band C. Fourth one is band D. So band A is our first digit, band B is our second digit, band C is the multiplier, band D is the percentage tolerance. So band A is what? It is our first digit, band B is second digit, band C is our multiplier, band D is our percentage tolerance. So Now if you see here, there are four bands here which are shown here. You can see four bands. Among four bands, how to decide which is the leftmost band, which is band A, which is band D? How to decide? How to distinguish between band A and band D? Okay, why? Because I have told you that band A is digit 1, band B is digit 2, band C is multiplier, and band D is percentage tolerance. So among band A and band D, how to decide whether uh, which is our tolerance band and which is our first digit band. So always whenever you you hold the resistors with your hand, so whenever you are holding the resistors, color coded resistors in your hand, so you must always check uh, the gap between the resistors band colors. Okay, what is the gap between the band colors? So if you see here in this four band color coded resistor, if you carefully observe, this brown, this red and this brown, okay, okay, they are closer to each other. The distance gap between these two resistors is small, whereas gap between this I'm sorry, third resistor and this I'm sorry, the gap between this third band and the fourth band is much more. You just carefully observe the distance between, or the gap between. So the gap itself represents that the band whichever is away from the rest of the bands is our tolerance band. Okay, the fourth band is much more far away from the remaining bands. So these three bands are closer to each other. That is, gap between these three bands is small, whereas gap of this fourth band is much more when compared to the gap between these three. So this is our tolerance band. Okay, so actually uh, three band color coded resistor is also available, but if you have a three band color coded resistor, it will not have any tolerance band. Okay, so three band color coded resistor will not have any tolerance band. Okay, only the fourth, fifth and sixth band color coded resistors will have tolerance band. So here, so there is sufficient gap between what? These three bands when compared to the fourth band. So this fourth band is our tolerance band. So always whenever you take the resistors in your hand, you just observe here this middle one. So you just observe here in this middle, in this image, you just observe this brown, black and orange. The gap is very small. Whereas the gap between this orange and this gold color band, okay, gap between orange and gold color band is much more. Okay, gap between this orange and this gold color band is much more. That means this gold is our tolerance band. And I'll just erase all the. Okay, so this is our band A. This is our band A. This is band B, band C, and this is band D. So this is our digit 1, digit 2, this is multiplier, this is tolerance. Okay, digit 1, digit 2, multiplier and tolerance. Now, so what is this when whichever band is much which is means whichever band is having sufficient gap between the remaining bands, Okay, you can see the gap between these three bands, okay, is smaller when compared to this band, this gold color band in this image. Okay, so this tolerance, so tolerance is in color coding refers to the percentage by which the actual resistance of a resistor can vary from the stated value. Okay, when we are calculating the resistance value of a resistor, color coded resistor, so one of the band represents what? This fourth band. It represents what? It is the tolerance. Tolerance is what? It refers to the percentage by which the actual resistance of the resistor for which we are calculating the resistance, it will vary from the stated value. Okay. So usually for four banded color coded resistor, the fourth band represents what? Tolerance band. So here the gold color band is our tolerance band, and the I'm sorry, where is it? Uh, so there are some common tolerance values for color coded resistors. So if the fourth band is gold color, which I have shown earlier, then the tolerance value is 5%. If the fourth band is in silver in color, then the tolerance value is 10%. So usually most of the four banded color coded resistors will have either gold color or silver color. So whatever resistance that value that we are going to calculate to that resistance, okay, whatever value that you get, so the actual stated value, actual value can be either plus or minus 5%, or if the tolerance is gold, or the actual value, it can be, actual resistance value can be plus or minus 10% of the calculated value. Okay, so it can be either greater than 5% more or 5% less if it is gold color, 10% more or 10% less if it is silver in color. Now if the fourth band, tolerance band, is brown in color, then the tolerance value is 1%. If the tolerance band is red in color, the tolerance value is 2%. If the tolerance band is green in color, then the tolerance value is 0.5. If the tolerance band is blue in color, then the tolerance value is 0.25%. If the tolerance band is violet in color, then the tolerance value is 0.1%. If the tolerance band is gray in color, then the tolerance value is 0.05%. Okay, so but usually uh, gold and silver, the tolerance band will be gold or silver in color. Most of the bands, it will be gold and silver in color. Okay, so usually for precision resistor, that is high precision resistors such as this six band color coded resistors, you can see the last band is red in color, and five band color you can see brown. So for most for five band color coded resistor or six band color coded resistor, the tolerance band, it may be sorry, it may be, it may not be gold and silver. And of course for sorry, for the six band color coded resistor, this fifth band is the tolerance, not the sixth one. Sixth one is the temperature coefficient. Okay, it is the temperature, sorry. Okay, it is the temperature coefficient value. Okay, for sixth band. So for sixth band as well as for sixth band as well as for fifth band, the fifth band is the tolerance. Okay, so for six banded color coded resistor, the sixth one is the temperature coefficient, fifth one is the tolerance. For five band, fifth one is the tolerance. These four bands are the resistance values. For sixth band, these four colors are the four colors are the resistance values. Okay, so for five band color code as well as for six band color code, the four colors, these four colors are the resistance values. For six band, four colors are the resistance value. Fifth one is the tolerance. Similarly here also for five band, fifth one is the tolerance. For sixth band, Sixth color is the temperature coefficient. It is not the tolerance. Okay. Okay then. So let us see how to calculate the resistance value for. I'm going to calculate the resistance value for the 4 band color coded resistor. So you can see here there are 4 colors here, 4 bands are there on this resistor. This is my digit 1, this is my digit 2, this is my multiplier, this is my tolerance. So for 4 band, the fourth one is the tolerance, third one is the multiplier, first two are the digit 1 and digit 2. What is the color here for first one? It is green, second one blue, third one orange, and fourth one is gold. Okay, so this is my table. Okay, this is my table in which I have written all the colors, digit 1 values, digit 2 values, third one is multiplier values, and this is my tolerance values. So how to remember this table? Okay, it's very easy to, you can write this table on your own. Okay, you can write them on your own. It's not a big task. You can do on your own. So, so how to do that? I will tell you. So where is it? Okay, I will tell you how to do that. Yeah. So I have compared the three um, resistors. You can see a 4 banded resistor, 5 band resistor, and 6 band resistor. You can see. So here you can compare them. I just you can see here 4 bands. You can see these three. First two are the digits, okay? Third one is the multiplier. Fourth one is the tolerance. For 5 band, first three are the digit. Digit 1, digit 2, digit 3. This fourth one is the multiplier. Fifth one is the tolerance. For 6 band, okay? First three are the digits. Digit 1, digit 2, digit 3. Fourth one multiplier. Fifth one tolerance. Sixth one is the temperature coefficient. Okay? Okay, so we have to follow some steps to read the 4 band color code. So first of all, I have already told you how to identify the digits and how to decide which one is the tolerance band, which is our first band 1 or band A, okay, or digit 1 band. So for that, now how to write this table, I will tell you. There is a saying that uh, there is a saying that B.B. Roy of Great Britain, okay, Great Britain had a very good wife, okay. B.B. Roy, if you remember this, that is more than sufficient to just write down this table. Just you have to remember that B.B. Roy of Great Britain had a very good wife, okay. So you just, if you see, some letters I have highlighted in red in color. Okay, so I have converted the color of some of the letters in red. Okay, BB Roy Great Britain, very good wife. Okay. BB Roy, Great Britain, very good wife. The off, had, a, these things, you just forget them. You just remember BB Roy, Great Britain, very good wife. Okay. So, so I'm going to take a table. Whatever I have written here, I'm going to erase it. So here I'm going to write B BB Roy. Okay, BB Roy. So this is the colors. Okay, I'm going to write the colors in sequence. R O Y. BB Roy, Great Britain, very good wife. Okay, so all the colors I'm going to write in a sequence so that it will be easy for you to follow. So this is it. So BB Roy, BB ROY Roy, Great Britain, very good wife. Okay. So now, first B represents black. Second B, of course, if one is black, another one is brown. Brown. Next, RED red. Next, orange. Y yellow. Next, green. Okay, this B is blue. This one is violet. Okay, next, gray. Next, white. Are you able to follow or not? You just mention in the chat box. Okay, now this is very easy to write it down. If you remember BB Roy, Great Britain, very good wife, you can write it down in a sequence and write down the full form of them in terms of colors. Now, simply in our next column, that is digit 1, it is a 4 band. I am writing for 4 band color coded resistor. So now 4 bands means 4 banded color coded resistor. 4 bands means digit 1, digit 2, multiplier, tolerance. Okay, 4 bands. 1, 2, band A, band B, band C, band D. Okay. So digit 1, digit 1, digit 2, digit 3, digit 1, digit 2, multiplier, tolerance. So let us write down digit 1. Okay. Digit 1 values 0. Just write down the sequence from 0 to 9. 2, 3, 4, 5, 6, 7, 8, 9. It's very easy, isn't it? If you remember, BB Roy, Great Britain, very good wife. Okay, you can write down the colors in sequence. Okay, so you can write down the colors in sequence, just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Simply for digit 2. For digit 2 also write down the same 0, 1. Write down numbers in sequence, that's it. 2, 3, 4, 5, 6, 7. Oh God. Wait, sorry, there was a disturbance. Somebody is playing with the crackers. Funny baat lega. Okay, 0. So digit 1 and digit 2 values we have written in a sequence. Okay. Now third one is what? It is the multiplier. Okay. So multiplier, third digit is multiplier. So third digit is multiplier. So what I need is I want to insert some symbol. I want to insert symbol, multiplication symbol. See, I have mentioned here multiplication symbol. So you just copy it and paste it for all the values. So see, it's a multiplication symbol I have inserted, and I want to insert some equation also. So here I'm going to write 10. Okay, I'm going to write 10 to the power of, to the 10 to the power of multiply. It's a multiply. 10 to the power of what? What is our digit 1, digit 2 value? 0. So 10 to the power of 0. So 10, how much is 10 to the power of 0? How much is it? 10 to the power of 0 is 1. Okay. What is my multiplier value now? For color black. For black color, gold and silver. Someone has mentioned gold and silver. Gold and silver are tolerance values. Sama, they are not. They are not. They are never. They won't. They are never. They will never come under this band A band B sequence. Okay. Gold and silver. They are always tolerance values. They will not. They will not be as. They will never be in digit 1 or digit 2. Okay. So I have not written gold and silver. I will write it now. Gold. See, I have even considered no color. Okay, so they will never digit under digit. They will never be gold and silver. Will never be under these three digit one, under digit one, digit two, and digit three. So, so for band means they can never be band A, band B, or band C. Gold and silver. They can never be band A, band B, and band C. They will always be the tolerance values. They will always be at band D position. Okay, fourth band. Okay, gold and silver are always fourth band. If there is no color at fourth band, then the tolerance is 20%. That is for three band coded. Okay, three band code resistor. Okay, so if it is three band code resistor, there will not be any band D. Okay, fourth band will not be there. Then tolerance is 20%. So I'm going to, so what is black? Multiplier of black is multiplier value. If it is black in color, if the band 3 or band C is black in color, then the multiplier value is 1. Similarly, I'm going to take another equation here. This is it. I'm sorry. So this is multiplier value 10. 10 to the power of for brown. Okay, for brown, 10 to the power of 1. 10 to the power of 1 means, what is the value? 10 to the power of 1 means 10. Similarly, similarly for red, 10 to the power of 10 to the power of what? Digit 1, digit 2 value is 2. So what is it? 10 to the power of 2 for red. 10 to the power of 2 means how much? 100? Is it 100? Similarly, all of you, anyone, you can write for other colors. In the chat box, you can mention other colors and you can write down the values. You can mention orange O. And what is the multiplier value for each color? If you tell me, I will write down quickly. Okay. Similarly, for green, 10 to the power of 5. For blue, 10 power 6. Okay. For violet, 10 power 7. Similarly, for gray, 10 power 8. 10 to the power of 8. And white, so 10 to the power of 9. Okay. So only the thing that you have to remember is usually tolerance values you have to remember remaining. If you know the BB Roy, Great Britain, very good wife. If you know that, you can write down this sequence. Okay, and you just in the table you mention digit 1, digit 2, write down the sequence of 1 to 0, 0 to 9, 0 to 9, and multiplier 10 power 0, 10 power 1, 10 power 2, 10 power 3, up to 10 power 9. Okay, and tolerance values you must remember brown and red. Is you can see brown will have 1% tolerance, red will have 2% tolerance. Okay, plus or minus. Okay, similarly green and blue, green and blue. Green will have 0.5% plus or minus 0.5% tolerance. Blue will have plus or minus 0.25%. Violet and gray. Okay, violet and gray. Violet will have 0.1% tolerance and gray will have 0.05% tolerance. And gold and silver, of course, I think you can easily remember, as well as for no color. Something happened, I don't know why. Okay. Okay then, for gold and silver, if you see here, gold is 5% plus or minus 5%, silver tolerance value is 10 or plus or minus 10%, for no color it is plus or minus 20%. So no color will be for only for that 3-band color coded resistor. If it is 3-band color coded resistor, only 3 colors will be there, 4th color will not be there. So for that, tolerance is plus or minus 20%. So you just look at this table. I hope it is easy. Are you able to follow or not? Mention in the chat box. This table you can write on your own. It's very easy. Is it easy or not? Just mention. Okay, now let us calculate the resistance value. For one resistor, I am showing you here. I have taken. You can mention in the chat box if you are able to follow. Now you can write. Now you can write table on your own. Okay. So you people calculate and quickly write down the values. See here. This is a 4-band resistor. What are the colors? You can see there is sufficient gap between these three. The gap between these three resistors is less. Gap between this band and these three resistors is more. So this is band A, this is tolerance. Okay. So whenever you look at gold or silver, immediately you can say that it is your tolerance band instead of checking for the gap. Okay. So if there is gold or silver, no need to check for the distance between or gap between the bands. Okay. That's it. Gold and silver are tolerance bands that you have to fix it. And gold and silver band should be considered at the right side. Okay. So you must hold the color coded resistor in such a way that the gold or silver color comes on the right side. Now let us start with band A, band B, band C and band D. That is first band and second band are digits, red color. Now if you are able to write the table, from the table, red means 2 and the second digit is also red. So second digit also 2. What is multiplier value into 10 to the power of, what is it? 2. So 10 to the power of 2. Gold means what? Plus or minus 5. So write down this 2 as it is. Write down this 2 as it is to know the resistance value. Both digit value should be written as it is. Okay, you should not multiply them, you should not add them or subtract them. Okay, first two digit resistance values, color values. Okay, not resist, okay, of course resistance value. First two digit color value should be written as it is. First two digit color value should be written as it is into multiplier value. Whatever multiplier value that you get, you just multiply it with that. Okay, and write down the units, that is ohms, plus or minus how much? 5%. So now 10 to the power of 2 means it is 10 to the power of 2, isn't it? Sorry. 10 to the power of 2 means 100. Okay. 10 to the power of 2 means 100. So it is 2.2 kilo ohms. Okay, it is 2.2 kilo ohms. So this triple red with triple red and gold, okay, resistor, this 2.2 kilo ohms resistance with plus or minus 5% tolerance, or 2200 ohms. I can say 2200 ohms. Okay, so now so let's go for the next one. You people do it and you just mention in the chat box, to give the answers in the chat box. Now let us see next one. What is it? Next one, in this you can see it is also 4 band color coded resistor. You can see digit 1 is red, digit 2 is violet, digit 3 is brown, digit 4 is gold. Okay. So I have written here red value is 2, violet is 7. So what is brown? Brown is our multiplier. So what I have to do is I have to take multiplier symbol. So into, it's not visible. Why? It's not visible here. I don't know why. It is superscript. So into symbol, multiplication symbol into equation. Now this is it. Now what is this? 10 to the power of, okay. What will you write? Brown means how much? Brown. It is color is how what? What is the color? It is brown. So brown means what? Brown means 10 to the power of how much? 1. Okay. What is the gold? Gold is plus or minus 5%. So now what is the resistance value? Write down first digit, write down second digit into what? Into the multiplier value. Okay. And write down this tolerance value. So ohm symbol, I will insert the ohm symbol here. Oh, right. Okay, I'm unable to find the. I will just copy it from here. I just copied it because I couldn't find it there. So what is it now? 270, 270 ohms. So red, violet, brown is 270 ohms. Yeah. Okay. So let us solve one more. Let us calculate the resistance for one more. So what is our digit one? It is brown. Sorry. This is brown. Digit one is brown. Next one is black. Multiplier color is what? Orange. And tolerance is gold. Tolerance is gold. So what is brown? From the table, brown is 1. Black is 0. And what about the orange? Orange is the multiplier. Third is multiplier. So multiplier. So it is why it is going as subscript. So what is it? 10 to the power of 10 to the power 10 to the power of what is the orange value? Orange is 3. So what about the gold? Plus or minus? Okay. So 10 to the power of 3 gold is plus or minus, sorry, 5%. So now write down the first digit value as it is. Don't multiply, subtract or add. Simply write down first digit as it is. First digit is 1. Second digit 0. Into what? Multiplier value. So you can see here it is how much is the resistance? How much is the resistance? 10 into 10 to the power of 3 means 10,000, isn't it? 10,000. 10,000 ohms. So or I can say 10 kilo ohms. Okay. So how much is this? It is 10,000 or 10 kilo ohms. Plus or minus 5% tolerance because fourth one is the gold. Okay, so it's very easy. You can write table on your own. One more last resistor and I will conclude this topic. One more last So last one. So it is also 4 band. You can see gold on the this right side. That means this is our tolerance. So let us write down red. First digit red, second digit red, multiplier is green. Gold and silver always represent tolerance. They will never represent digit 1, digit 2 or multiplier value. So what is meant by red? Red value is 2 from the table. This red value is 2 from the table. What is green? They have written 5 into, insert into equation. It's 10 to the power of 5. Okay, now copy it as it is. Okay, so into 10 power 5, not 5. Okay, simply I just went with the flow. So that's it. So how much is the resistance now? Okay, so it is very high value actually. So we can't even mention in kilos. Okay, so 22 into 10 power 5 ohms. Okay, so I can write it in kilo also. It is approximately, I can say, 2200 kilo. So it is how much? It is 2200 kilo ohms. Okay, so resistance is 2200 kilo ohms with plus or minus 5% tolerance value. So what is it? So I hope you are able to follow. So this is a small table which I thought it will be easy for you to um, easily write down the resistance value if you have this sort of table. So these are few resistors. Okay, so this table, you can write it down very easily. If you remember what? If you remember this. If you just remember, not this, you just remember this. If you just remember B.B. Roy of Great Britain had a very good wife, you can so you can write down on your own. Okay. So if you have so, so if you have this 5 band or 6 band resistor. Okay, if you have 5 band or 6 band resistor, so you can see here this is a 6 band resistor. So let me see where is my 5 band. 4 resistors. No, so if you have 5 or 6 bands, so what you have to do is you have to first identify the first 3 bands which represent the first 3 digits of your resistance value. The fourth band will indicate what? Multiplier. Whether it is 5 band or 6 band, The fourth band will represent the multiplier. First three will represent the resistance value. Fourth band will represent what? Multiplier. And fifth band will represent the tolerance value. For fifth band as well as sixth band resistor, fifth band will represent tolerance. And sixth band is available only for six band coded resistor, not for five band. That is temperature coefficient. So temperature coefficient is available only for six band code resistor, not for five band. Okay. So if you have this also you can do it. You just write down three digits in your table. Okay, multiplier value and tolerance. Temperature coefficient you need not write it down. Okay. So I hope you are able to follow this concept. So you just mention in the chat box whether you are able to follow or not. Okay. So I tried my best in the simplest possible way to explain this concept. So you just mention in the comment box whether this concept was easy to you or was it difficult to understand. Okay, then I'm concluding this topic. Thank you for attending the class. And write your comments if you want any other topic, any lecture you want, any online lecture on any topic, just in the comment box. So you just like and share so that it will be many people will be able to go through this topic.
Oi.